Hi everyone, my name is Mitchell and I am a computer science major from RPI.
And my name is Herta. I'm also a computer science major from RPI.
And we're going to talk to you today a little bit about infectious diseases. So, can someone tell me what they think an infectious disease is? Yeah, you in the back.
It's a disease that can be spread from person to person.
Exactly. So, what about a disease like asthma? Is asthma an infectious disease?
No, because you're born with it and you can't spread it.
Right, that's exactly the case. So, asthma is a disease, but it's not infectious because we can't spread it from person to person. So what about something like the cold or the flu?
Yeah, definitely.
Right, exactly. That is an infectious disease. So we're going to talk to you today about some different types of infectious diseases, and then also how these infectious diseases can spread from person to person. But because none of us like to get sick, there are ways that we can stop these diseases from spreading, and that includes stuff like vaccines. So we'll talk about how vaccines work and how they're effective. And then we'll also talk about current efforts in helping us stay healthy and minimizing the spread of infectious disease.
Yeah. So, infectious diseases are not one size fits all. Some of them are caused by bacteria and some of them are caused by viruses. So, bacterial infections can be caused by a bacteria that is living in the situation. So it doesn't need a medium for it to spread, since bacteria are living organisms. In this, which is just living beings, and they're very small. In this slide, we can see how bacteria spreads in this petri dish, which is essentially just a little bowl of scientific jello that is food for the bacteria. So as you can see, it started out being pretty slow, and very quickly we see these white spots and darker areas in the red gel, and that means the bacteria has spread throughout it. But on the other hand, we have viruses. Viruses can't spread on their own, so they really need something to latch onto. As we can see in the diagram, they latch onto something that is alive to be able to spread their disease. And can anybody tell me anything that looks kind of like this that they've seen in the past?
Think like spaceships. Yeah,
Aliens?
like the moon lander.
Oh, okay.
Yeah, so the moon lander deposits humans onto the moon in a way that's kind of similar to how the virus, injects the disease onto a living thing.
Right. So humans can't survive in space by themselves, but we have the spaceship carries us there just like a virus carries its information to a living host. So there are several common ways for diseases to spread all around us. So what are some common ways that they can spread?
Shaking hands with somebody else.
Right, yeah, shaking hands. What about if it's kind of, your nose is a little stuffy and achoo. Yeah, like a sneeze, or maybe coughing would be another way. Anything else? Anybody ever get, feel a little bit sick after maybe eating some food?
Yeah.
Right?
Sometimes.
Yeah. So food contamination is also another way that diseases can spread. So this is why we always have to cook our meats and our eggs and make sure that we keep our food refrigerated or frozen and do all those safe practices. So at this point in the presentation, we'll kind of break character. We do an activity with the kids. So we give basically all of the kids, we fill up these cups with either tonic water or seltzer water. So the cool thing about tonic water is it has quinine in it, so they don't need to know that, but all they need to know is that it glows in the dark, like this really kind of fluorescent blue color, where seltzer water does not glow, but they look pretty much identical. So we start out with about however many cups we need for the class. We fill 2 to 3 roughly with tonic water, and then we have the kids go around and kind of share water basically with everyone else. So everyone will have a syringe with them, and then kind of we'll share water. And then, just with a little bit of water, it actually will turn these cups blue too, so that was clear before because of seltzer water. So now we see that there's multiple people are sick, per se, and then after doing this for a couple minutes, we'll kind of have all the kids, line up, and then they'll one by one check their cup to see if they're sick or not sick, and then we take a tally at the end. So the whole point is we're kind of seeing how quickly diseases are spreading throughout people. So after this,
We will
we
continue.
continue the presentation, and we say, hey, so wasn't that crazy how fast diseases spread throughout our class population? So how do you guys think that diseases spread? Like what kind of pattern? Do you think that it is exponential or linear? So those are kind of big words, so we're going to break them down a little bit. So linear spread or linear growth means that it's just one at a time. So say if I'm sick to start off with, and I get Herta sick, and then Herta gets one of you sick, and so on and so forth. It's only one person at a time. Do you guys think that diseases spread just that way?
No, because everyone that gets sick can get more people sick.
Right, exactly. So once I get Herta sick, it's not just Herta that gets other people sick, but it's also me. So it's really kind of this whole pyramid or upside down tree, if you will. This is called exponential growth. So it's just like you might be learning in your math classes right now about exponents or multiplication and how quickly this can really grow and get much bigger. So here's kind of a little video to illustrate that. So we have this student here who is about to drop a ping pong ball into this large kind of box, glass box full of all these other 100 ping pong balls on mouse traps. So does anyone have a hypothesis as to what would happen? Anyone?
Anyone? As soon as the ball drops into the pit, what do you think is going to go on inside there?
At first, only a few are going to jump up, but then more and more and more are going to.
Right, that's a good hypothesis. So let's take a look and see what happens. And it's exactly that. So at first only a couple balls go, but as soon as it starts going, it's just mad chaos everywhere. And that's basically what exponential growth is, and that's how a lot of diseases spread. So this is kind of a graph that shows this, but you can see how much faster after only a few generations, a few instances of getting people sick, how it can really spiral out of control really fast. Some diseases though spread quicker than others. So diseases like Ebola, how many of you have heard of Ebola?
I've heard of
a few
it.
hands, yeah, a few people. So it's a really scary disease. It's really nasty and it's a very serious thing, very high fatality rate. Not good to have. But the good thing about Ebola is that it spreads much slower. So if you look back at this graph, that would be like the blue line at the bottom, kind of. It doesn't spread as fast as another disease like the flu or like measles that has a much higher infection rate. So the Ebola infection rate is about 1.3 or so, which means it's a very gradual kind of increase. Where measles, which is kind of like chickenpox, but it spreads super fast. If someone has measles, it's very easy to transmit to other people. So it spreads much faster and has a much steeper line.
So all this information has been getting kind of scary, right? There's diseases everywhere and they grow so fast. So what do we do to stop them? How are we not always sick all the time? Well, the answer to that is vaccines. So vaccines provide a sort of what is called immunity, which means you are safe from an infection that gets to you. So if I have a vaccine and an infection comes to me, it'll not infect me. But if I didn't have it, it would infect me. And here we have just like a little diagram of how vaccines kind of work. So what vaccines have in them, it's not a little magic juice they inject in you, but what they really give you is a version of the infectious disease that won't affect you. It's completely inactive and it's not possible to do anything to you. And the reason why we put this in the body is to train our cells to respond to it. So these cells know exactly how it looks. And so they know how to combat it. It's kind of a wanted poster, but for the human body against diseases.
Right. So at this point then, again, we do another activity. So kind of similar to the first one where we have a bunch of different cups. However, instead we kind of say, all right, now we're going to practice safe practices, or we're going to do safe practices to keep us safe and to prevent the spread of disease. So one thing that we learned is to do things like cover our cough or our sneeze, make sure we cook our food and all that. So this will limit the number of people that we're transmitting it to. So instead of just having the students go out and share water with everyone around them, we will just take a few students and kind of have them go in a circle and then say, just share it to the person to your right. So this way it's kind of less spreading, you're stopping that exponential spread. And then we also give some students, usually 2 or 3, a red solo cup, so it's opaque. So we say that this is a vaccine, And we say, all right, well, if you have the vaccine, you can't get sick, so nobody can put any water into your cup. You can't get any germs. So then again, we do that, have them encircled, and one by one they come up and they test to see if they're sick or not with the black light. And then from there we can kind of take a tally and we'll see, oh, well, the disease, much less people got sick this time because we were, practicing good hygiene by not spreading disease to everyone, and some of us got vaccines, but not everybody.
Yeah, and at this point, like, we'll usually keep the tally on the board. So at this point, the students can really see like the shocking difference between them. They're usually pretty blown away by the fact that only a couple students got vaccines, and mostly everyone's okay.
Right.
Anyways, continuing. Vaccines can be very effective because they can protect not only the person itself, like we saw in the activity, they can protect everyone around that person. So can anyone think of someone that's in contact with so many people during their day? So if they're sick, they could get lots of people sick?
My teacher, Mr. Z.
Yeah, Mr. Z, definitely. Because teachers, mail delivery people, sales clerks, they're in contact with so many people throughout the day that if they have a vaccine, it would really prevent the spread. Because let's just pretend one teacher sees 100 students a day. If one of those students is sick and gets the teacher sick, the teacher will get sick about 100 students. But if the teacher is vaccinated, those 100 students will be perfectly fine, even if one of them is sick. So we have a little bit of an example of something that happened a while ago. So this is a map of the areas that were affected by smallpox in the year 1945. So for all you history fans out there, can anyone tell me kind of what was going on before or during 1945?
World War II.
Yeah, so because of the war, why do you think the war would affect something on a very